All right, this is trigonometry in a nutshell. Okay, so I am assuming that you have the basic knowledge of trigonometry, what is an angle, uh, types of triangles, its properties, etc. Okay, so let's consider a right triangle ABC. Okay, so right triangle ABC. Okay, so this is A, this is B, and then this is C. This is now side A, so opposite of A. Then this is B, and then this is side C. The sign, or rather, we have, before that, we have a code, if you remember. So, ka, to, wa. That is, the sine of any angle is opposite over hypotenuse. The cosine of any angle is adjacent over hypotenuse. The tangent of any angle is opposite over adjacent. Okay, so let's consider angle A. Okay, so angle A. So in this case, sine A. So sine A is A over C. Okay, so opposite over hypotenuse. So this is the opposite side, and this is the hypotenuse. Cosine A, B over C, and tangent A is A over B. The inverse of sine is cosecant, and it is abbreviated as CSC. Cosecant of A is simply the reciprocal of A over C. So that is C over A. And then we have secant for cosine. So secant A, C over B. And tangent, the reciprocal of tangent is cotangent. Okay, so cotangent A is B over A. All right, so
LOL.
let's have a sample problem. So a guy wire, 15 feet long, is fastened to a point 13 feet above the foot of a vertical pole, which stands on level ground. Find the angle that the wire makes with the horizontal. Okay, so we have a pole. So this is our pole. So just imagine this is a straight line. Okay, and then you have a guy wire. So this is the guy wire. How long is the guy wire? 15 feet. Okay, so 15 feet. And the pole, the vertical pole is 13 feet. So the question is, what angle does the wire, so this wire, makes with the horizontal? Okay, so let me designate this as angle A. Okay, so angle A. If you remember the 6 trigonometric functions of an acute angle, and in this case, I will be using sine. So sine A, is opposite over hypotenuse. So 13 over 15. And angle A, so A is arc sine. So arc sine, so raised to -1. So arc sine of 13 over 15. And using your calculator, this gives you 60.07 degrees. Right. With this, I'd like to introduce to you, or rather reintroduce, the Pythagorean Theorem. So I know you have taken this in your previous years. So let's just go over it. The Pythagorean theorem states that that the square of the hypotenuse is equivalent to the sum of the squares of the two sides of a right triangle. Okay, they say that the Pythagorean theorem is the most proven theorem. Okay, so let's see. So we have three sides and then four sides of the triangle. So if I were to make a square, this, okay, so if I were to make a square, okay, oops, make a square,
Lamau.
and then this one. So how many squares do I have on this side? I have 9. Okay, so 9 squares. And over here, so on the other side of the triangle, if I were to make a square, okay, so how many squares do I have on this side? 16. Okay, so 16 squares. Um, on this side, if I were to make a square, okay, if I were to make a square, so if we count the number of squares we have on this side of the triangle, we have 25. So that is 5 square. Okay, so 5 square. Okay, over here. Okay, so 5 square is equivalent to 3 square plus 4 square. And that is 5 square or 25. Okay. Let's proceed with the trigonometric functions of special angles. Um, let me draw an equilateral triangle. Okay, so let me draw an equilateral triangle. So this is 60 degrees equilateral triangle. So this is 60 degrees, 60 and 60. Okay. Now, let's say that the sides of the equilateral triangle are 2. Okay, so 2, 2, and 2. If I were to drop a perpendicular line from the vertex, okay, if I were to drop perpendicular line, then this side is now 1. Okay, so 1. So the height of the triangle, applying the Pythagorean theorem, gives you square root of 3. Okay, so let me draw that triangle over here. Over here, and then this one. Okay, so this is 1, 2, and applying the Pythagorean theorem, solving for the height of the triangle. This gives you square root of 3. So this is 60 degrees. Okay, so this is 60 degrees. And this is 30 degrees. So considering, let's say, the sine of 30. So sine of 30 is, from this triangle, is 1 over 2. Cosine of sine 30 is adjacent over hypotenuse square root of 3 over 2. Tangent of 30, so let me write that one. So tangent 30 is opposite over adjacent. So 1 over square root of 3. However, we do not want a radical sign under the denominator. So what we'll do is to multiply this by square root of 3 over square root of 3. So square root of 3 divided by square root of 3 is 1, so we're not changing anything. And this gives us square root of 3 over 3. Okay? Now let's, and other functions, of course, you can do this, but I'll show this on the table on my next illustration. For a right triangle at 45 degrees, okay, so for a right triangle at 45 degrees, so this is 45, okay, so this is 45 degrees, given the size as 1, and then this is 1, so solving for it, this is square root of 2. So we can see that tangent is 1, so 1 over 1, and then cosine 1 over square root of 2, but as I've said, we do not want a radical sign under the denominator, and so let me write that one. So cosine 45 is 1 over square root of 2, and so I multiply this with square root of 2 over square root of 2, and this gives me square root of 2 over 2. Okay? Let me show you this table, so rather a summary of the values for the special angles, okay, of the triangle. You can see, as I've said earlier, so sine theta or sine 30 is 1/2. Then cosine of 30 is square root of 3 over 2. And then tangent 30. Okay, so tangent of 30 is square root of 3. So I already explained how we arrived over here. So you don't have to memorize this. Okay, so you don't have to memorize this, but rather understand how we got to these values. Okay, so just memorize these triangles. Okay, the values of these triangles, and then you should be able to complete the table. Now, take note that tangent 90, okay, so this is 90, or over here, so it is undefined. So it is undefined. Okay, we have radians and then degrees. So let me show you how to convert radians to degrees. Remember that 180 degrees is equivalent to pi radian. Pi radians. Okay. So let's say that you are given, so I'll just use this one, so 45. So let's say that you're given 45 degrees and you are asked to convert 45 degrees into pi radians. So all you have to do is multiply this with, so this is 45 degrees, so this is 180 will be the denominator, and then this is pi radian, and this gives us an answer pi over 4. Okay, so this is pi over 4 radians. Same thing if you are given a pi over 3. Okay, so let's have this an example, pi over 3 radians. So all you have to do is multiply this with, so in this case radian is the radian should be the denominator, so pi radian, and then this is 180 degrees, and this gives you 60 degrees. Okay, let's consider a square, or rather a rectangle. So let's consider a rectangle. Okay, so a rectangle. and this is your base, and this is your height. If I were to, okay, so before that, what is the area of a rectangle? Base multiplied by height. So that is the area of a rectangle. Okay, rectangle. If I were to divide the rectangle into two, like this, okay, like this. Um, Sorry, let me have a good division. It's the same. Oh well. Anyways, you know what I'm talking about. So this is equally divided. Okay? So just imagine this is equally divided. So the area of the triangle now is 1/2 of the rectangle, right? So area of a triangle is simply 1/2 base times height. Okay. And with that, let me introduce another formula in getting the area of a triangle, rather. And this is what you call Heron's formula. Okay, so Heron's formula, when all three sides of the triangle is given, so area is the square root of s, so s minus a, s minus b, s minus c, so square root, where a, b, and c are the sides of the triangle, and s is 1/2 of a plus b plus c. Okay, so let's have a sample problem here. Right, so we have a Cartesian coordinate system, and we are asked to construct a triangle given the following vertices. Okay, so vertex A is -1, so this is my y-axis. Okay, so y-axis and then x-axis. So let me write that one. So y-axis and then x-axis. All right, so let's connect the lines. Is C. So C 9 3. Okay. Uh-huh. So let's consider this one. Okay, so this one I will put a line like this, then this one. Okay. So we have a right triangle. Okay, right triangle, right triangle. Let me get the distance. Okay, so from here to here. Okay, so I dropped a line from this point. Okay, so I want to get the distance from here to here. So what is this distance? So the distance is simply 9 minus 5, right? So let me designate that as d sub x. So 9 minus 5. And then this one, the distance from this point up to this point is simply, so let me designate that as d sub y, d sub y. So that will be 3 minus negative 7. So this one gives us how much? So 9 minus 5 is 4. Then this one gives us 10, right? So 10. Okay. What could be the distance now of this one from here up to here? Considering that we have a right triangle. Okay? So, all we have to do is apply the Pythagorean Theorem. So that is, the Pythagorean Theorem is c squared a squared plus b squared. Okay, but c squared is simply this distance. So I will replace it with d. Okay, distance d. So d squared, and then a will be, okay, so let's designate it of this one as d sub x. So that will be d sub x squared, then plus d sub y squared. Right? Now, d sub x is, if I were to designate this one as x sub 2, and then y sub 2, and this one as x sub 1, y sub 1, then I can replace d sub x and d sub y with, so following this one, so x sub 2, so this is x sub 2 minus x sub 1, then this is y sub 2 minus y sub 1. So from here we can, so let me erase this one. Okay, so let me erase this one. I will now write it like this. This is now x sub 2 minus x sub 1 square plus y sub 2 minus y sub 1 square. Taking the square root, okay, so taking the square root, so I will now erase this one. So my eraser is very big. So this one, okay. Okay, so taking the square root, and this gives us the distance formula. Okay, this gives us the distance formula. This one, distance formula. So the distance formula came from, or is derived from, the Pythagorean theorem. Now, in getting the area of the triangle, so why did we go over here? Because we need to get the sides, or the distance, or the length, AC, AB, and then BC. Okay? And to get the distance, we'll be using the distance formula. Okay? So let's continue. So distance, so let's solve for, so earlier, let's consider BC. Okay, so BC. So let me designate BC like this. So D, then BC. So square root of. So again, I have shown it to you earlier, this one. So x sub 2, x sub 1, y sub 2, y sub 1. Okay, so that will be 9 minus 3 square plus 3 minus negative 7 then square. Okay. And the distance in that distance DBC is, using your calculator, and this gives us 2 square root of 34. And so distance AC, so distance AC, okay, so distance AC, so that will be 9 minus -1, so this is square, plus 3 minus 1. Okay, so make sure that you are consistent with x sub 1, y sub 1, x sub 2, y sub 2. Okay, so otherwise you'll get the wrong answer. Then square. And distance AC, again from your calculator, this gives you 2 square root of 26. 2 square root of 26. Then next is distance BC. Distance B. Oh, no, not BC. AB. Okay, so distance AB. So distance AB. AB. So that will be 5 minus -1. Okay, so 5 minus -1 plus -7 minus 1. Okay, so this is 7. Okay, so -7. Okay, square. Okay, and using your calculator, this gives you 6 square root of 2. 6 square root of 2. Now we have the 3 distances or length of the triangle. So we are now ready to solve for the area. So to solve for the area of the triangle, we'll be using the Heron's formula. All right, so let's so Heron's formula, when all sides of the triangle is given, so area is the square root of s minus a, s minus b, s minus c, and then square root. And s is 1/2 of a plus b plus c. So what is s? So let's solve for s first. S is 1/2 of, so this, so we have 3 sides of the triangle, so that is 2 square root of 34 plus 2 square root of 26 plus 6 square root of 2. And this gives us 15.17. Okay, so 15.17. So let's now continue for the area. So area This gives you an answer of 42.06. Okay? Let's now proceed with interpolation. So with interpolation, I am reminded of the conversion between degree C to degree F, vice versa. Okay, so what's the formula for converting degree C to degree F and then degree F to degree C? Okay, um, so degree C to degree F, vice versa. Okay. What I know, so I haven't memorized the formula, but what I know is that for degree C, okay, for degree C, the boiling point of water is 100 degrees Celsius. And the freezing point of water at degree C is 0. For degree F, okay, so degree F, the boiling point of water is 212 degrees Fahrenheit. And the freezing point is 32 degrees. Okay, so if I were to do like this, so get the difference of degree C minus 0 divided by this one. Okay, so divided by this one. So 100 minus 0, and that should be proportional to, so whatever I did on the left side should be done on the right side. So this will be degree F minus 32 over 212 minus 32. Okay. So simplifying this one, we now get degree C over 100, then degree F minus 32 over 180. So 180. If I were to solve for degree C, degree centigrade, degree Celsius, then degree C, degree C is 5 over 9, simplifying 100 over 180, 5 over 9 of degree F minus 32. And if I were to solve for degree F, then degree F is 9 over 5 of degree C plus 32. And that is the formula in converting degree C to degree F to degree C. And this is what do you call, so the process on how I got the formula for degree C and degree F, interpolation. Okay, so this is interpolation. Right, so let's have a sample problem. So let's have a sample problem. I want to get from the table, okay, so from the table, I want to get, okay, so over here, so I want to get 18 degrees 15 minutes. Okay, so 18 let me write that one. So 18 degrees 15 minutes. Okay, without using my calculator. Okay, so without using my calculator. Okay, so without using my calculator, but instead I'll be using interpolation to get the approximate value of the sine of this angle. Okay, so the sine of this angle. So let's so what do we do is that we look for a value that is in between this one. So that will be 18 degrees 10 minutes, 18 degrees 20 minutes. So 18 degrees 15 is in between these two values. So I'll write it like this. So 18 degrees 10 minutes, and then 18 degrees 20 minutes, and then in between is the one that we are looking for. So 1810 has an equivalent of for sine. Okay, so we are looking. So let me write that one. So we are looking for the sine. Okay, so for the sine of 18 degrees 15 minutes. The equivalent of sine 18 degrees 10 minutes is 0.3118. Then this one is 0.3145. And the desired value is, let's designate that as x. Of course, I'll be doing it like this. So this one minus this one. So the answer is negative 0 degrees. Where is that? So 0 degrees 5 minutes over, so this one, difference between the two is negative 0 degrees 10 minutes. And this should be equivalent to x minus 0.3145 over 0.3118 minus 0.3145. And this one, okay, so this one gives us an answer of 0.5. So let me continue over here. So 0.5 is equivalent to x minus 0.3145 over negative 0.0027. And multiplying both sides of the equation by negative 0.0027, this gives us negative 0.00135, then x minus 0.3145. Adding both sides of the equation by 0.3145, solving for x gives us 0.31315. If you input this one, if you input this one straight to your calculator, trigonometric functions, this is approximately equivalent to, so this one is almost equivalent to the one in the calculator, 0.31316. Okay, so they're almost equal. Okay, so that's a sample of interpolation. Right. Let's have another example here. So we are to evaluate secant 46 minutes, 46 degrees 27 minutes when from the table, cosine 46 degrees 20 minutes is equivalent to 0, 69,
LOL.
05, and cosine 46 degrees 30 minutes is equivalent to 0, 68, 84. So, first thing to do, let me write this one first. Second, 46, then 27 is actually equivalent to 1 over cosine of 46 degrees 27 minutes. Right? Okay. So, let's get the equivalent value of cosine 46 degrees 27 minutes by means of interpolation. So we write 46, 20, and then 46, 27 minutes, and then 46, 30. Then we have the equivalent 0.6905,
OMG.
and this is x 0.6884. So again, employing what's this? Interpolation. So we start here. So that will be 46, 27 minus 46, 30 over this one. Okay, this one. Then 46, 20, 46, 30. So I forgot to put this one over here. Then this is equivalent to x minus 0.6884 over, then this one 0.6905
Lamau.
minus 0.6884. And solving for x gives you, okay, so x gives you 0.68903. So, cosine of 46 degrees 27 minutes, okay, so the cosine of 46 degrees 27 minutes is this value. So I can now write this as, okay, so 1 over 0.68903. Okay? And finally, I now divide this. I now evaluate this one, and this gives me how much? 1.45132. Okay, so that is the second of 46 degrees 27 minutes using interpolation. Okay? So let's proceed to the next topic. So this time we now have the trigonometric identities. trigonometric identities. Let's recall that from the Pythagorean theorem, so from the Pythagorean theorem, that c squared equals a squared plus b squared. If I were to divide this, if I were to divide this by c squared, this one will become, so 1 equals a squared over c squared plus b squared over c squared. I can write this like this. So 1 is equivalent to a over c squared plus b over c squared. Now, if we are to consider this angle A, what is A over C from here? So let's consider this angle. Okay, so let's consider this angle. What is A over C? A over C is sine A. So I can write this one as sine square A plus, what is B over C? B over C is cosine square A. And that is one of the trigonometric identities. Okay, one of the trigonometric identities. You can continue this on your own by instead of dividing this by c squared, you have you use now a. So okay, so let me do it here. Okay, so c squared equals a squared plus b squared, and then instead of c, I'll be using a squared. So this one now becomes c over a squared, and then 1 plus b over a squared. So from here again, considering angle A, so this is cosecant. Okay, so A over C. So A over C is sine. So the inverse C over A is cosecant. So cosecant square A is equivalent to 1 plus, so B over A. So from this angle, A over B is tangent. So tangent A is A over B. So the reciprocal is cotangent. So cotangent square A. All right. So I leave the other trigonometric identity for you to solve. So you do the same thing. Instead of dividing it by a squared, you now divide it by b squared. Right? Continuing, if I'm continuing, let me show you that again from this side of the triangle, so angle A, we have, let me write here, tangent A is A over B. Right, so opposite over adjacent, A over B. If I were to multiply this by 1 over C divided by 1 over C. So am I changing anything? Yeah, of course not. So 1 over C divided by 1 over C is 1. So if I were to multiply 1 to a over b, I'm not changing anything. So I will now evaluate this one. So tangent A is now a over c over b over c. Now again, from the triangle, what is a over c? A over c is simply sine A, and b over c is cosine A. So that's another trigonometric identity, that tangent A is sine A over cosine A. Right? The same thing is true if I were to write, or rather you can derive sine A as, so A over C. So I will multiply this by 1 over B over 1 over B, and this one becomes A over B over C over B. And sine A is, what is A over B? A over B is tangent A. What is C over B? So C over B, that is the inverse of B over C. So B over C is cosine. The reciprocal of B over C, C over B is secant. So this is secant A. Alright, so I leave the other function, cosine A, for you to derive. Alright, this is the summary of the formula for the trigonometric identities. So so we have the sum of the angles, sine A and B, cosine A and B. So sum and difference for the sine and cosine function, and for the tangent function, then we have the double angle formula. So this is tangent 2 theta, cosine 2 theta, sine 2 theta. Then we have the half angle formula. All right. So let's have a sample problem. Okay, so let's have a sample problem wherein we are to evaluate cosine 15. So cosine negative 15 using values of special triangles and employing trigonometric identities. Okay, so cosine of negative 15 can be written as cosine of 30 minus 45. Okay? So 30 minus 45. So here, this is A, and then this is B. So I have a sort of a pattern for the formula, so that I'll just share it with you. So, I have here sak, kas, and kak, sas. So in this case, for the cosine function, okay, so for the cosine function, this one is now equivalent to, okay, so cosine A. So cosine A is cosine 30. Then cosine B, so that will be 45. If this is minus, okay, then this should be plus. As opposed with the uh, sine, sum and difference of two angles for sine. If it is plus, then this should be plus. So let me continue now. So I'm on this side now. So SAS, that will be sine 30. Okay, so sine 30 and then sine 45. So what is cosine 30? So cosine 30 is square root of 3 over 2. And cosine 45 is square root of 2 over plus. So sine 30 is 1 over 2 multiplied by sine 45 is square root of 2 over 2. And evaluating this one, it gives us square root of 6, 4 plus square root of 2 over 4. And that's the final answer. So I can write it like this. So 1/4 and then square root of 6 plus square root of 2. Right, so let me continue over here. Cotangent, what's this? Cotangent 75. So this is 75. 75 equals 3 minus square root of 3 over 3 divided by 3 plus square root of 3 over 3. And we can see that it's now cancelled. So we're now left with 3 minus square root of 3 over 3 plus square root of 3. Of course, we do not want to have radical signs under the in your denominator. So what I'll do is simply multiply this with 3 minus square root of 3 over 3 minus square root of 3. So this expression is actually 1. Okay, so 3 minus square root of 3 divided by 3 minus square root of 3 equals 1. So I'm not changing anything. Okay. So this one is now equivalent to, okay, so this is 3 minus square root of 3 square. And then this one, some difference of two squares. So we now have 3 square minus square root of 3 square. And this one is, so we now have 3 square minus 2 times 3 square root of 3 plus square of square root of 3. And this one is, so 3 square is 9 minus 3. And evaluating this one further, this gives us how much? So this one is 9 minus, so 6 square root of 3, and then plus 3 over 6. And this is, so 12 minus 6 square root of 3 over 6. And finally, we get 2 square root 2 minus, so 2 minus square root of 3. Okay, so I take the common, so I divided this expression by 6, so I now have 2 and then square root of 3. Alright, so this time we are to prove that the tangent 3a is equivalent to this expression. Okay. So tangent 3a, so let me write it here. So tangent 3a can be written as tangent of 2a plus a, right? Okay. So tangent 3a, okay, so tangent 3a is equivalent to tangent 2a plus tangent a over 1 minus tangent 2a tangent a. Tangent 2a can be simplified further. Okay, so that can be simplified further, and this can be written as 2. Okay, so this one, tangent 2a, okay, so tangent 2a is 2 tangent a over 1 minus tangent square a, then plus tangent a over this one, so we have 1 minus, again, tangent 2a, this one, tangent 2a is this one, so we have 2 tangent a over 1 minus tangent square a, and then multiplied by tangent a. Okay, so I will now combine terms. I will now combine the values in the numerator and then the denominator, and this gives us what? So this is 2 tangent a plus tangent a multiplied by 1 minus tangent square a over 1 minus tangent square a. And then this is divided by this one, the denominator, so 1 minus tangent square a, okay, so this one multiplied by 1, then minus this one, so 2 Okay, so 2. Okay, so I'll be multiplying this one over here. So 2 tangent square. Okay, so 2 tangent square A. And then 1 minus tangent square A. And with this, we can see that this one and this one can be cancelled. Okay, cancelled. Right. So let me continue. Um, this one is now 2 tangent A plus tangent A minus tangent cube A. Then this one, so 1 minus, so I will now combine this one and then this one, 1 minus 3 tangent square A. And to simplify this one, this is now 3 tangent A, so I combine this one and then this one, minus tangent cube A over 1 minus 3 tangent square A. Alright, so that's we have proven that tangent 3A, okay, so that tangent 3A is equivalent to 3 tangent A minus tangent cube A all over 1 minus 3 tangent square A. Alright, so new topic, trigonometric functions of any angle. Okay, so if you recall that an angle, so you have your initial side, so this is your initial side, and then this is your terminal side. So initial side, and then the terminal side. And an angle is usually measured like this, counterclockwise. So if an angle is like this, okay, angle is like that, okay, so measured like this, it is positive. Okay, so positive. If an angle is measured like this, so here up to here, okay, the angle is expressed in negative. Okay. So there's no specific reason why counterclockwise movement is positive and clockwise movement of an angle is negative. There's no specific reason. It's a customary one. Okay. Um, let's consider the rectangular coordinate system. So you have your y-axis, then the x-axis. Okay, so y-axis, then the x-axis. This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. You have the term abscissa, that is your x coordinate, and for the y coordinate, that is what you call ordinate. So you have your x and y coordinate. The x coordinate is called abscissa, y coordinate is called ordinate. We can see that x and y are positive over here. So positive, positive. So for the x and y coordinates, this one it's negative and then positive. Over here, it's both are negative. Okay, so both are negative. Then this one, positive and then negative. So we always uh, write x first, the x coordinate. In the coordinate system, so if we consider an angle theta, okay, so we consider an angle theta, okay, consider an angle theta. So this is your y again, and this is x. Okay, so let's say we put an angle. We put, and this is, we designate this one as r. Okay, so r. And then this is your angle theta. Okay, from here. Okay, so this is your angle theta. Okay. So previously, we were just dealing with acute angles. So what if the angle is more than 90 degrees? In this case, it's more than 90 degrees. So um, uh, we will consider that we have the y coordinate and then the x coordinate over here. Okay, and this is now your reference angle. This one. Okay, so this one. This is your reference angle. Okay. And from here, this is your y. So this is your y, and this is your x. We can see that sine theta, sine theta is actually the sine of your reference angle. So this is your reference angle, and the sine of the reference angle is, okay, so the sine of your reference angle, sine of the reference angle, as I've said, is actually your sine theta, and that is y over r. Same thing for cosine theta, x over r. Tangent theta, y over x. And the of course the equivalent inverse of sine, that will be cosecant, so that will be y r over y. So cosecant theta is r over y, and then secant theta is r over x. Cotangent theta is x over y. For example, so let's consider, okay, much better. Okay, so again, this is your y and x. So let's consider, okay, so this is 2, okay, then this is angle theta, this one. So this is angle theta, or rather 120 degrees. So angle theta is 120 degrees. So the reference angle this time, okay, so the reference angle will be 60. This one, the reference angle, so that will be 60 degrees. Now, if this is 2 and this is 60, then by the special triangle, we know that this one the x coordinate, the abscissa is 1, and the height is of the triangle is square root of 3. So sine 120, so sine 120 is actually equivalent to the reference angle 60 degrees. So that will be sine 60. And that is square root of 3 over 2. So opposite of this angle, this one. So square root of 3 over 2. So same thing for cosine. Cosine of 120 is equivalent to the reference angle here, which is cosine 60, and that is negative 1 over 2. Tangent 120. So again, from the reference angle, that will be tangent 60. So opposite over adjacent, square root of 3 over negative 1. Okay. Now, let's have an example wherein, let's say that sine theta is equivalent to 1/2, but the terminal side, okay, so we have a condition that the terminal side falls in quadrant 2. Okay, so here we can see that we have the this table wherein at quadrant 1 all functions are positive. Quadrant 2 only the sine and cosecant is positive, the rest is negative. Quadrant 3 only tangent and cotangent is positive. Quadrant 4 only cosine and secant is positive. You don't have to memorize this, but understand the how you got this one by, okay, so by where is it? By understanding that sine theta is y over r, cosine theta is x over r, tangent theta is y over x. So depending on so on the given values, you'll be able to determine which is positive and negative. So, yeah. So over here, we are given sine theta as 1/2, but the terminal side falls in quadrant 2. Okay, so this is where it falls. So sine theta 1/2, but it falls in quadrant 2. So this is quadrant 2. So sine theta falls in quadrant 2. Okay, so this is this is sine theta. So again, sine theta 1 over 2. Again, how do we define sine theta? Sine theta is y over r. Y over r. So this one is 2. Okay, so r is 2. And y is 1. Y is 1. So this is 1. This one. Okay, this is 1. So if we are asked to get the value of the abscissa, or the x-coordinate. This one, we are asked to get this value. So we will simply employ the Pythagorean theorem, wherein r squared is equals to x squared plus y squared. So r is already known, y is already known, so we can solve for x. So this is now 2 squared and then x squared plus 1 squared. And x is square root of 3. Okay, so that's how we draw the triangle when given such conditions. So in this example, so sine theta is equivalent to 1/2, but it falls on the second quadrant. All right, so this time let's evaluate sine theta given negative 2 over 3. And the condition this time is that cosine theta is positive. Okay. So cosine theta is positive. So for cosine to be positive, so again, let me write cosine theta over here. Cosine theta, what is cosine theta? X over r. For cosine theta to be positive, x must be positive. So for now, I will be taking r to be always positive. Okay, so it's always positive. So we'll just vary. So x and y can be positive or negative. So for for cosine theta to be positive, x should be positive. And so that gives us these two quadrants. Quadrant 1, okay, so quadrant 1 and then quadrant 4. Okay, so quadrant 1 and quadrant 4. Here, x is negative, so cosine is negative. Now, given that sine theta is negative 2 over 3, again, what is sine theta? Sine theta is y over r. So we can see now that y is negative. So if y is negative, so it should be somewhere here. So this is okay. So let me draw this one over here. Okay. So 1, 2, negative 2. So this is negative 2. So meaning the angle is on quadrant 4. Okay. So angle is in quadrant 4. So this is now, and this is 3. Okay, so this is 3. So angle theta is like this. So from here all the way here. So that is your angle theta. So what is this angle theta? So that is what we'll be looking for, and then the x coordinate. So again, employing the Pythagorean theorem, that r squared equals to x squared plus y squared. So this is 3 squared. Then x squared is unknown. Then y is negative 2 squared. And x is square root of 5. So square root of 5. And that is approximately 2.23. So 1, 2. Okay, so somehow I got the correct length for the radius 3. So x is square root of 5. So what is now this angle? This angle, okay, so we will be solving for the reference angle. We need to solve for this reference angle. So let me designate this as okay, like this, beta. This is so sine beta is this one, so 2 over 3. 2 over 3. But then 2 is negative. And this gives us negative 41.81 degrees. Okay, so to get angle theta, we simply subtract 360 to this one. So the negative sign, okay, so just to be clear, the negative sign indicates that it falls in quadrant 4. Okay, so it falls in quadrant 4. So again, reference angle 41.81. So angle theta is simply 360 minus the reference angle 41.81. So I am disregarding the negative sign over here. So I'm disregarding it. So again, the negative sign indicates that the quadrant that the angle lies in quadrant 4. Alright, so this time we have the same value. Sine theta equals negative 2 over 3. However, there are no conditions. No conditions. So again, this is y over r. So previously the answer we had is that okay, so this is 2, then this is 3, this is 3. So negative 2, so y over r can be like this. Okay, it can be like this. Okay, it can be like this. So we have two possible solutions. So earlier we already solved for this one. This time I'll concentrate for this one. So the angle theta is over here. Angle theta is over here. And the reference angle, of course, is this one. Okay? Reference angle is this one. We'll be forming a triangle here. Then this one. Okay. So earlier we solved for x. So let me show you one more time. So we have r squared equals to x squared plus y squared. And of course, I'll just do a shortcut here. And so x is square root of 5. Okay? So solving for the reference angle. Okay, so this is 2, then this is 3. So in this case, so same thing. So cosine beta, that will be square root of 5 over 3, and beta is 41.81 degrees. Okay, so this time, angle theta is this angle 180 plus the reference angle. So earlier, for this one, we have the whole 360, then I subtracted the reference angle. So this time I am adding the reference angle. So 180, that is, okay, so 180 plus the reference angle. So this is the solution for this side. And for this side, so for this side, we already solved it earlier. Okay? Now, we are on a new topic, angle of elevation and depression. So from the figure, we can see that this is the observer and this is the horizontal line. So the angle of elevation is like this, okay? And angle of depression is like this. We have another example. So depending on the where the observer is, so for the cat, this angle is angle of elevation. However, for the bird, so for the bird, the same angle is called angle of depression. All right, let's have a sample problem. We have a cliff 250 meters high, and the angle of depression of a boat is 10 degrees. So let me draw this one like this, okay, over here. So 10 degrees, so where is 10 degrees? Angle of depression. Okay, so this is your horizontal line, so this is your 10 degrees. Okay, so this is your 10 degrees. So this is 10, then this one, so this one. Okay, so this angle is how much? That will be 80 degrees. We are given that the height of the cliff is 250 meters. So how far is this one? So how far is the boat from the foot of the cliff? So what function are we going to use? Opposite over adjacent. So that will be tangent. So tangent 80 is the distance of the boat. So that's let me designate that as D. Okay, so let's let me write here D. So D over 250. Solving for D. Okay, so solving for D. D is 250 multiplied by tangent 80. And that distance is 1417.82 meters. All right, another sample problem. Let's have another sample problem here. from the top of the building, so 200 meters high. So this is 200 meters. So from here to here. So this is 250 meters. 250 meters. Okay. The angle of depression to the bottom of the second building. Okay. The bottom of the second building is given as 20 degrees. Okay. So this is 20 degrees. Okay. So this is 20 degrees. Let me put an arrow like that. Okay. And then this one, this is now 10 degrees. This one. Okay. So 10 degrees. Okay. So the question is, how high is the second building? So for us to solve this one, we need to consider first this triangle. In this triangle. Okay. So let's solve this triangle first. So in order for us to solve this one, if this is 20 degrees, okay, so this is 20 degrees from here to here, then this is also 20 degrees. Okay, this is also 20 degrees. So knowing this, we can solve for this distance. We designate it as D. Okay. Tangent. Okay, so tangent. So opposite over adjacent. So tangent 20 is opposite over adjacent. So 250 over D. So D is 686.87 meters. So the second triangle is this one. Okay. Okay. So we will now consider this triangle. So, and we will designate this one. So from this point up to this point as x. Okay, so let's solving for x. So if this is 10, okay, so this is 10, then this is also 10 degrees. Okay, so we will get the value of x. So tangent 10 is equivalent to x over 686.87, and x is 121.11 meters. So if this is x, we can now solve for the height of the second building. And the height of the second building is simply 250 minus x. So 121.11. So the height of the building 128.89 meters. All right. This time, for our next topic, solution of oblique triangle. We have the sine law. Okay, so let me write it here. So sine law, and for an oblique triangle, so we have a over sine a, that is equivalent to b over sine b, equivalent to c over sine c. Okay, so oblique triangle, so the triangle can be like this. Okay, oblique triangle. And we have the cosine law. Okay, we have the cosine law. Cosine law is c squared equals to a squared plus b squared minus 2ab cosine c. And a squared is, okay, so b squared plus c squared minus, so 2ab, so this will be 2bc cosine a, cosine a. Then for side b, so b square is a square plus c square minus 2ac cosine b. Alright, so let's have this sample problem wherein we have two surveyors and they need to determine the height of the cliff. So this is the cliff, so they need to, and they are 50 meters apart. Okay, so let me draw that one over here. So they are 50 meters apart. And this guy, okay, so, no, better put it here. Okay, so from the transit, okay, so from the transit like this. Okay, so 50 meters with each other, and then the surveyor measures the angle of elevation from the base of the cliff to the highest point. So from here to here. Then this is your drop line. Then from here. So from the base of the cliff. So how much? 61 degrees. So this one is 61 degrees. Then he also measures the angle between Alice and the base of the cliff. So if this is Bob, so this is Bob, this is Alice. So let me designate this as B. Okay, so this is B, Bob. This is Alice. Okay, so A, Alice. So the angle from here to here, how much? 72. Alice also measures the angle between Bob and the base of the cliff as 38. So from the same point that they have agreed upon, the angle is, for this one, how much? 38 degrees. So how high is the cliff? Take note that from this point up to this point, this one is a right triangle. So this is a right triangle. So first, we need to get this length of the triangle. So this one, we need to get this one. Okay, we need to get this one. And to solve that one, we'll be employing the sine law and or cosine law. So in this case, this is 50 meters. So let me label that one. So this is 50 meters. Okay, 50 meters. So what is this angle from here to here? What is this angle? So this angle is, so let me designate that as angle C. Okay, so angle C is 180 minus 72 plus 38. Okay, like this. Okay, so the sum of the angles in a triangle is always 180. So angle C is 70. So knowing angle C, we can now solve for this side. So let me designate this as side A. Okay, side A. Let me write that one. So this one is side A. This one, okay, so this one, the yellow part, so side A. So employing sine law, A over sine A is equivalent to C over sine C. So what is A? We do not know. But sine A, so that is 38. So sine 38. And then C is given as 50. Sine 72. Sine 70, sorry. So sine 70. So sine 70. Okay, so this 72 is for this one, for this angle. So A, solving for A. So what is A? So A is 32.76 meters. So knowing A, okay, so knowing A, and we have this angle. So knowing A, this one, and we have this angle as 61, then we can now solve. So considering that this is a right triangle, we can now solve for the height of the cliff. So let me designate this one as H. Okay, so H. So tangent 61. Okay, so over here, this angle. So 61. This angle is 61. Tangent 61. That will be height opposite over adjacent. Adjacent side is 32.76. And H is 59.1 meters. Okay. Now, if we consider the height of the transit as 1 meter, then the final answer should be 60.1. Okay. In that case, since we are considering the height of the transit, then there is a 1 meter gap from the way this one is measured, because a transit will make a horizontal line, then all the way up to the cliff. Now, if the height of the transit is not mentioned, so nothing is mentioned about the height of the transit, then the final answer is 59.1 meters. I hope I am clear with that one. So again, if the height of the transit is given, okay, so the instrument used to measure the angles by the engineers, then you need to add that one to this answer. Otherwise, if nothing is mentioned, then 59.1 meters is the final answer. Alright, another example. So a lighthouse is 10 nautical miles northeast of a dock. So if this is our dock, okay, this is our dock. So take note of our compass. So I have included the compass here. So northeast, okay, so northeast. So that is 45 degrees. 45 degrees. So the lighthouse, okay, so the lighthouse is, where is the lighthouse? Located 45 degrees. Okay. So this is 45 degrees. Let me draw that line over here. Then we have a ship. Okay, so we have a ship leaving the dock. Okay, so this is the ship. Then it sails east. It sails east. Okay, so it sails east over here, over here. Okay, until uh, until the distance, it is 8 nautical miles from the lighthouse. Okay, it is 8 nautical miles from the lighthouse. So this is 10. Okay, so this is 10. Lighthouse is 10 nautical miles northeast of a dock. Okay, so this is 10 nautical miles. Then this is 8 nautical miles. So the question is, at what time the said ship will be 8 nautical miles from the lighthouse? Let's get first the angle rather. So this is 45. 45. I need to know this angle. So let me designate this as A. So this is A, and then this is B, and then C. So from sine law, 8 over sine 45 is equivalent to, okay, so 10 over sine C. Sine C is 10 multiplied by sine 45 over 8. Oh, so sine C, okay, and this gives us how much? Angle C is 62 degrees, 6 minutes, 51.96 seconds. Now solving for this distance, but before that, before we can solve this distance, we will get this angle A here. So angle A, simply 180 minus the sum of angle B, which is 45, plus angle C. And A gives us 72 degrees, 53 minutes, and 8.04 seconds. And with that, we can now solve for this distance traveled by the ship when it is 8 nautical miles away from the ship. So A squared is equivalent to B squared plus C squared minus 2AB cosine A. So A is, okay, so unknown, A is unknown, B is 8, 8 plus C is 10, 2 times 8 times 10 cosine A. Cosine 72 53 and 8.04 centimeters. So A, 10.81 nautical miles. Nautical miles. Okay, so 10.81 nautical miles. So I'm abbreviating nautical miles as NM. Okay, this is the usual abbreviation for nautical miles. However, this is in conflict with the SI unit nanometer. But as far as maritime application is concerned, then this abbreviation is normally used or accepted for nautical miles. Let's now solve for at what time will it be 8 nautical miles from the lighthouse. Knowing that speed is distance per unit time, so we want to know t, time. So time is distance over speed. So speed is given as 12 knots, and distance d is the one that we solved earlier, which is a, 10.81 nautical miles. So t is 10.81, so 273. So I'll be using up to 5 decimal places divided by 12 knots. So 12 knots is 12 nautical miles per hour. So I forgot to put the unit here. Nautical miles. So unit nautical miles is cancelled. You're now left with hours. And the time is 0.90106 hours. Okay? And that is the answer to that question. So does it make sense that it's almost an hour? Yes, considering that the speed of the lighthouse is 12 knots. So meaning in 1 hour, it should have traveled 12 nautical miles. However, you can see that the distance traveled is only 10.8 nautical miles. So that means to say uh, it has traveled less than an hour, which is zero point 0.9 hours. All right, so we have 3 ships, A, B, and C. So let me designate this one as A, and then that's this B. So we have 3 ships. So A, B, and C are anchorage area. So A to B is 300. Okay, so this is, so let me designate this as C. Okay, so C. Let me designate this as C. Okay, so it will be like this. Okay, so let me write it here. So this is C, this is B, and this is A. So why did I put B? So why did I put it like this? Because in the problem statement, B being due north of C. So if this is C, then north is over here. So A can be over here or over here. Doesn't matter. What is important is that B is north of C. So we now have a triangle. This, so north, straight line. This, and then this. So question is, find the direction of B to A. So AB is 300, so this is 300 nautical miles. Then AC is 194 nautical miles. And then BC is 160 nautical miles. So to solve for the angle, or for the direction, okay, so direction or angle. So what is the direction of B? So this one. Okay, so what is the direction of B to A? So we will employ cosine law. So if this is B, then this should be a side B, and this is side A, and this is side C. So B squared is A squared plus C squared minus 2AC cosine B. B squared, so B is 194. So over here, 194 squared. Then A is 160 squared plus C is 300 squared minus 2 times 160 times 300 times cosine B. So solving for cosine B, cosine B is 6497 over 8000. And angle B is 35 degrees, 41 minutes, and 45.34 seconds. Now, the direction, so we are asked for the direction of B to A. Okay? B to A is like this. So it should be written like this. So if this is north, okay, this is north, so we have our compass like this. So we have north, east, west, and south. So in this case, the angle it makes is like this, like this. Okay? This one, this is the angle. So therefore, the direction of B to A should be written like this, east of south. Okay, so east of south, 5 degrees, 41, and 45.34 minutes. West of south. Okay, so sorry, west of south. So 35 degrees, 41 minutes, 45.34 seconds, west of south. So this is south, west of south, going to the west. So if we position this shape over here, then we will get the answer, except that direction will be east of south. Okay? And that will be my introduction for course and bearing. Okay, so course and bearing. As I've said, bearing or direction, that is the position of an object or anything to the observer, relative to the observer. So in this case, let's say that the ship this ship is traveling east, okay? Traveling east, like this, east, okay? It's traveling east. Then the course of this ship is simply east. However, the bearing of this ship as observed from this ship is not east, but when it can be uh, south, maybe 30 degrees or 40 degrees south or east of south. Yes. So let me write that one. I have my compass here. Okay. So this direction, this, so north, east, west, south. So east of south for this one. Okay. Now, relative to the dock or to the port, okay, so let me put this one over here to be like this. Okay, so the bearing of this ship will be east of north. Okay, so north. Okay, so north, east, west, and south. Okay, so east of north. Over here, east of south. Sometimes, instead of, okay, so how do we write this one? So when we say east of south, so bearing is east of south, it's like this. So you have angle and then east of south. So any angle, so 40 degrees, 30 degrees, whatever, east of south. For here, okay, for in this case, for the dock, then it will be east of north. So angle and then east of north. Okay. Um, if the ship is over here, okay, so let's say that the ship is uh, in this position. Okay, so this will be, so from here to this one to this point. So you have this angle, so west of north. Okay, so west of north. Now, again, course is where you are going. Bearing is the position of another object to the observer. So let's have a sample problem. So a ship is sailing due east when a light is observed bearing 62 degrees 10 minutes. After the ship has traveled 2,250 meters, the light bears 48 degrees 25 minutes. If the course is continued, find the closest distance from the light the ship can get. So let's let me create a compass here. This. So it is said that from here up to this point, okay, up to that point, uh, okay, so from true north, okay, so true north, okay, so from here, okay, the angle makes is 62 degrees 10 minutes. Then the ship traveled, so the ship traveled to east, okay, so anywhere, okay, so anywhere can travel such that the ship has traveled 2,250 meters. So let's say it's somewhere here, okay? Somewhere here. And Okay, so how did I figure out that it should be over here and not here? Basing from the bearing of the light, 4825. So 4825, if I were to create another one, okay, 4825, okay, like this. This angle, this one is 48 degrees 25. Doesn't look good. Let me write it over here like this. 48, 25 minutes. Okay, so find the closest distance from the light the ship can get. So if the course is continued, so ship's traveling again. From here all the way here to the east. Let's go to the east. So the question is, what's the shortest distance or the closest distance? So we can observe that the ship can be anywhere, can be over here. So if it is over here, is it the shortest distance from the lighthouse or from the light? Over here, over here, over here, over here, over here. Okay, so as you go further, the distance is becoming longer and longer. And we can observe that the shortest distance is over here. Not here, not here, but over here. In other words, it makes a right triangle. Okay? It makes a right triangle. So, like this. Okay? So, like this. A right triangle. Alright, so this is 90 degrees. Okay, so this is 90 degrees. So 90 plus this one, so 130. So this one is 130 degrees, 25 minutes. This one. Okay. So in this case, if this is 138, then what could be this angle? This one. So this angle is,
But before that,
this one is 62. So this angle is, so how much? 27 degrees and 50 minutes. This one. So this angle um, will give us 13 degrees and 45 minutes. So how did I get with this? First, took this one. So this is 48. This angle is 48. So plus 90. So again, this is 48. This is given. And then plus 90. So that is 138 degrees 25 minutes. This is given as 62. So minus. So it's subtracting it to 90. Gives me this angle. So this is 27 degrees 50 minutes. Okay. And with that, I add this one and then this one. Subtract the value to 108 to 180 degrees. This is the answer. So alright, so let me, I'll just write it. Okay, so 180 minus sum of 138, 25 plus 27 and 50. Okay, so next is that we will solve for this distance. We will solve for this distance in preparation uh, on how to get this distance later. So we will solve this one. So let me designate this one as side C. Okay, so this is side C. This one, side C. Okay. So in this case, using sine law, so C over sine 128.25 is equivalent to this angle over here. So 250. So consider this one, 250, this distance, and then the opposite angle. Opposite angle is 13. Okay, so sine 13 degrees 45 minutes. So again, C is this one. So consider this one C, and then this one to 250, and then opposite angle is 13. Okay, this one 13. 13 degrees 45 minutes. So C is 6282.846628 meters. Okay, meters. Now, as I've said, the shortest distance will be a straight line from here to here, and that forms a right angle. And with that, I will now use sine this angle, which is 27 degrees 50 minutes. Opposite, so let me designate that as distance D. So let me designate this one as D. Okay, this one is D. D over the hypotenuse, which is C. I'll just write C, okay? So I'll just write C. And C is this value. So D is 2933.47 meters. And that is the closest distance that the ship can get from the lighthouse, from the light. Finally, for our last topic, vector. Okay, so vector is a quantity having magnitude and direction. Okay, so magnitude and direction. So again, direction is angle or bearing. Okay, so let's consider that if this is A, okay, so this is A, and it is being displaced to point B. So this is object. This is your object A being displaced at point B, and finally reaching the final destination at C. Okay, so it's like this, going from here and then going here. The distance or the displacement A to C, okay, displacement A to C is your resultant. Okay, so let me write that here. Okay. All right, resultant. And it doesn't matter which one is first. I mean, it can be B to C and then A to B, and you will still reach the same resultant. So meaning, if I were to have this one first, if I were to displace originally this object and do it like this, so it will be like this. So this will be point D. And then later do A to B. Still, I will arrive at point C. Okay, so it doesn't matter. Let's have a sample problem for this one. So we have three forces, 20, 30, and 40 pounds respectively, and they are in equilibrium. So find the angle that they make with each other. So let's say that this is 40, so this is 40 pounds, and then another, this is 20, and then 30. Since they are in equilibrium, can be said that there should be an equal and opposite uh, equal and opposite force over here, somewhere here. So this one is the equivalent of 20, and this, so I can put it over here. So I now have a triangle. So this triangle, this one, okay, so this one, I now have a triangle, this one, and so we do not know what angles they make with each other. So let me designate this as angle A, angle B, and angle C, right? So this triangle, so again, let me put 40 over here, and 30, and then this is 20. In this case, we'll simply use cosine law. Okay, so again, cosine law is c squared, a squared plus b squared minus 2ab cosine c. So for c, so okay, so let me, so ab properly delineated. So 40, then a is let me erase this one, okay, and put it over here. So this is 30, so that it's easy to see. It's opposite, okay, a. So this is 30 square plus 20 square minus 2, 30 by 20, then multiplied by cosine c. And cosine c is negative 0.25. And angle C, 104. Okay, so angle C is 104 minutes 39.04 seconds. Angle A, 30 square, then 20 square plus 40 square minus 2 times 20 times 40 cosine of A. Okay, so opposite of 30, that is A. Cosine A. And angle A is 46 degrees, 34 minutes, and 2.87 seconds. And for angle B, so for angle B, so this is 20 square, and then 40 square plus 30 square minus 2 times 40 times 30 cosine B. Okay, so this one, opposite of 20 cosine B. And B is 28 degrees, 57 minutes, 18.09 seconds. All right. So this is the last problem set. and we have a ship being pulled by tugboats as shown. So of course, there are lines attached to it. Okay, so there are lines attached to it, and normally tugboats will push, okay, instead of pull. Now, just imagine that someone grabs your hand. Okay, so someone grabs your hand, and you are being pulled. So as you're being pulled, your whole body can feel the force, okay, the pulling force. So imagine that one with the ship. So as the tugboats are being pulled, the forces are concentrated on the center of mass. And we can represent that one as like this. Like this. So this is the Cartesian coordinate system, and the origin is the center of mass of the ship. And with that, we can now delete the ship. So we are now left with the tugboats. These tugboats can, the forces exerted by the tugboats can be represented by lines like this. And we can now delete the tugboats. And finally, we put the labels as mentioned in the problem statement. And this is now your free body diagram. So the free body diagram is a representation of the forces acting on a body. I will now label the first tugboat as T sub 1, T sub 2 as the second tugboat, T sub 3 as the third tugboat. And with this, I have simplified the diagram. So earlier, it was like this, wherein direction or course of the tugboats are expressed in true north. Okay, so true north. So formerly, we were expressing the course as east of north or west of south, and so on. But this time, um, course is expressed in terms of true north. So true north is um, direction from the north. Okay, so from the north clockwise. Okay, so from the north clockwise. So that's why here we have 40 degrees for the first tugboat, 120 degrees for the uh, second tugboat, and this one for the third tugboat. Okay, so the simplified version is this one. So I subtracted 90 to 120. And this gives me 30. And of course, the whole value from here all the way here, I subtracted 270. And now I am left with this angle. All right. So let's answer this one. So we are to calculate the resultant force and its direction. All right, so let's consider this triangle and this one. Okay, so all the way here. So this is now your x component and y component of the force T sub 1, representing tugboat number 1. And the force exerted is 150 kilonewtons. So to get the x component, we have the given angle here. So that will be, so sine 40 is equivalent to the x component, so opposite over hypotenuse. So x component, so let me designate that one as T sub 1 x over 150, which is your hypotenuse. And T sub 1, okay, so T sub 1 x is now equivalent to 150 sine 40. And that is 96.41814. For the y component, this one, for the y component, so let me put the label here. So this is x, and this is y. Okay. So for the y component, we'll be using cosine 40, then adjacent. So y component will be t sub 1 y over hypotenuse 150. So t sub 1 y is 150 cosine 40. And that is equivalent to 114.90667. All right, so that's for t sub 1. Next is t sub 2. For t sub 2, let's consider this triangle from here all the way here. Okay? This triangle. So same thing, we will solve for the x component. So this is your x component, and then y component. For the x component, this is cosine 30. This will be t sub 2x. Okay, so t sub 2x over hypotenuse, which is 360. So t sub 2x is equivalent to 311.76915.
OMG.
And for the y component, we have sine 30 t sub 2y. Okay, so t sub 2y over 360. And t sub 2y is 180. For t sub 3, let's consider now this triangle, this one, and this one. All right, so again, we solve for the x component. Solve for the x component, so that will be cosine of that angle is equivalent to t sub 3x over 260. And t sub 3x is equivalent to 240. For the y component, we have sine of this angle, 22 degrees, 37 minutes, 11.51 seconds. T sub 3y over 260. And t sub 3y is 260 sine 22, 37, 11.51. And t sub 3 is the y component for t sub 3, 100. Okay, so let's make a summary of the x component and y component. So for the x component, for t sub 1, we have, okay, and t sub 2, and t sub 3, now take note that the x component for t sub 3 or t sub 3x is negative. Why it is negative? Because, as you can see over here, that it is going to the left. So the x component lies on this side. So it should be negative. So I will write here negative. So you now have a negative sign. Okay? So let's continue on the y component. T sub 1y is and T sub 2y and T sub 3y. Okay, so again, let's consider the sign. Okay, so for the y component of T sub 1, it's positive over here. So it is on this side. The same thing is true for the y component of T sub 3. It's going up. Okay, so it is on this side. However, for T sub 2, it is over here. So it should be negative. Negative. So I will put negative sign. So I will now take the summation of forces along x and y. For x, we have this value. 168,18729 kilonewton. And for y, we have 3490667 kilonewton. And with that, we are now ready to compute for the resultant force. And the resultant force is the square root of the summation of forces or vector along x plus the square of the summation of vectors along y. And this is and R is 171.77 kilonewton. And that is your resultant force. For the direction of the resultant force, we have tangent theta as summation of y over summation of x. So theta is arctan of and angle theta is 11.73 degrees. So if I were to illustrate it, if I may illustrate it, it will be like this. So the resultant force will be like this. So this is your resultant and this is angle theta. Take note that angle theta is always measured along the x-axis as far as the resultant is concerned. Now, depending on the sign of your summation for x and y. So let's say x summation of forces along x is negative, then the angle will be over here. Okay, so the angle will be over there. So this one. So it will be like this. Okay? Now, if y is negative and x is positive, then it will be over here. If both x and y are negative, then it will be in this quadrant. Again, angle theta is measured along the x-axis. Okay? So along the x-axis. Now, if we are to represent this as true north, okay, so as true north, representing this one as true north. So let me write that one. True north. Then we need to subtract this angle theta to 90.
Lemao
So
means learn math always
90
okay.
degrees minus angle theta. And that is for true north. And this is trigonometry in a nutshell. And always remember, Lemao.
Lemao means learn math always okay.
Yeah, all right.